All right, here is the continuation of the periodic behavior of the sine, cosine, and tangent function. So go ahead and pause if you need to read this more slowly on your first slide. Why do trigonometric functions model phenomena that repeat indefinitely? By starting at point P on the unit circle, so here is our unit circle, and we have some point. If we continue around the unit circle another revolution of 2 pi or 4 pi or 6 pi, we return to that same point, x comma y. So here would be one more revolution around of 2 pi, another revolution around of 2 pi, another revolution of 2 pi. So the period for a sine function is 2 pi. The period for a cosine function is 2 pi. But notice for the tangent function, it is just pi. So the period for the sine and cosine function is 2 pi. And the period for the tangent function is just pi. There are certain patterns in nature that repeat again and again. For example, the ocean level. So if you have a wave, continues that pattern, that's in regards to the low tide and high tide. And they go back to low tide approximately every 12 hours. If low tide occurs at noon, then high tide will occur around 6 p.m. Low tide will occur again around midnight, and so on indefinitely. If the f of t function represents the ocean level at a beach time, they would say the revolution around the unit circle would be 12 hours. So this is how you would write your periodic function equation. So one cycle for this application problem is 12 hours. So here's an example. The height of the water h in feet at a boat dock t hours after 6 a.m. is given by this function. So this is a trigonometric function. And we want to find out the height of the water at the dock at these time frames. So we'll start with 6 a.m. So the time is 6 a.m. So you're going to substitute 6 into that equation. So h equals 10 plus 4, the sine of pi over 6 times 6. And what's going to happen is this 6 and that 6 will cancel out. We have 10 plus 4 times the sine of pi. Now I'm going to just create a quick coordinate plane. Here's 0 radians, and here's pi over here. It has the order pair, -1, 0. Remember the y is your sine value. So the sine of pi is 0. So 10 plus 4 times 0. 4 times 0 is 0, so you get 10. So when the time is 6 a.m., the height of the water is 10 feet. Let's do one more, and then I'll give you the rest of the answers. So let's do 9 a.m. So at time of 9 a.m., we would substitute 9 into that equation for t. And we're going to reduce that 6 and 9 by a common factor of 3. So that's going to be 3 halves. So where is 3 halves on the unit circle? That's down here. It has the order pair over 0, down 1. This value is your sine value. So we're going to substitute -1 in for positive 3/2. So let me finish writing that. So 10 plus 4 times the sine of 3 pi over 2, and now that exact value is -1. And then we simplify it, and we get 6. So at 9 a.m., it's 6 feet. We would continue doing this for noon, so we'd substitute 12 in. So I'm just going to give you those answers. So when the time is noon, we would get 10 feet. At 6 p.m., we would get time of 12 hours, and we would get 10 feet. At midnight, which is 18 hours later, you'd substitute 18 in, and you would get 10 feet. All right. When is the low and the high tide? So when is it its highest, and when is its lowest? So if we think about that previous part, here is 3 pi over 2, which was 9 hours later. When it was 9 hours later, we would have 6 feet. So I'm just highlighting this time here. 6 feet. And then at pi over 2, or 3 hours later, it would be, this is the low tide, and then the high tide was at 6 a.m. at 10 feet. And then it says, what is the period of this function? What does it mean about the tides? The period of a sine function is 2 pi. So every 12 hours, the revolution starts over again.